Welcome to this video. This is practice test 3 that I have on crackap.com. The topic is rational functions. Okay, so if you have not done these problems before, I recommend you do them beforehand, and then, of course, the website does have the answers there and even explanations. I didn't look at explanations though, so if the explanation there did not make sense to you, hopefully this video can help you out to help understand some of the problems and seeing how I approach them also. Okay, so which of the following is equivalent to limit as x approaches infinity of 4x squared over x squared plus 5000x? So when we approach infinity or negative infinity, that's asking about end behavior. So is there an asymptote in this case, or does it grow to negative or positive infinity? In this case, it's a rational function. So there's an asymptote. What is the horizontal asymptote in this case? It would be, we check the degrees, they're the same, so we take the ratio of the leading coefficients. So it would be 4 over 1. The horizontal asymptote will be y equals 4 over 1, which is y is 4. Answer is D. Okay? There's a way to calculate this limit actually, and you'll learn that in AP Calculus, but we know that this is a horizontal asymptote, so we can quickly do that degree test. This is the quick way to do it. There's a way to calculate it actually, and you'll learn that in AP Calculus, but that's a little more tedious. And it's not needed for this multiple choice question anyway, because multiple choice, you don't need to show work. Graph of which of the following equations has y equals 1 as an asymptote? So this is a horizontal asymptote. Okay, so we got to be careful. So that means, similar like we did up here, the degrees have to be the same, and that means the degree of the ratio of the leading coefficients should be 1 over 1, or even negative 1 over negative 1. It has to be either case. And the choice that has that is choice B. Okay, why is it not A? Well, the degree of the top is bigger than the degree of the bottom. That means there's no horizontal asymptote. And there's a slant asymptote though, which this is a horizontal line, so not A. Similar logic, same logic for this, degree of the top bigger than degree of the bottom. Okay, which of the following is the end behavior asymptote for the function this guy? Okay, as I just said, the degree of the top is bigger than the degree of the bottom, so there's no horizontal asymptote. There is a slant asymptote though, so that's why they have 4 choices of linear lines. How do we find the slant asymptote? We can do long division. That's how I would approach it, because I don't remember how to do synthetic division. Or I probably do, but I'm not the best at it, because I always have to try to remember how to do it. So long division I know how to do though. Okay, so to get an x cubed, I need to multiply this x squared by x. So we get minus, so we multiply x to everything. X cubed minus 3x squared minus 4x. So we subtract the 2. X cubed minus x cubed is 0. There's no x squared term on top, but this becomes a plus 3x squared. And then we have a plus 4x. There's no x term on top, so it's plus 4x. And then when we bring down the minus 8. Okay, and then to get 3x squared, we need to multiply this by 3. So it'll be minus 3x squared minus 9x minus 12. I don't care what the remainder is. I just care that the horizontal asymptote is x plus 3. Answer is C. I should circle the C, but whatever. Okay, which of the following equations could represent the graph? That's in the next page. So it's this one. Okay. Let's take a quick look at it. Now let's look at the choices. So we probably want to first figure out, clearly there is a horizontal asymptote at y is equal to 0. And there's vertical asymptotes at, this is x is negative 2 and x is 2. Okay, so we got to probably find pieces of information that give us that. Okay, so for A, B, and C, we can factor the bottoms. I'll do it for the first one as x plus 2, x minus 2. So the bottom, we can factor it like that. So we can see that choice A, B, and C, there would be vertical asymptotes at x is minus 2 and x is 2, because these two values, we would be dividing by 0 then. Okay, so that's why it's a horizontal asymptote there. While for this one, we would factor it as x plus square root 2, x minus square root 2. The vertical asymptotes would be x is minus square root 2 and x is plus square root 2. So that's not the answer. Now we got to take care of the horizontal asymptote. We do the degree test. There would be a horizontal asymptote when the degree of the bottom is bigger than the degree of the top. And that's only the case when it's A. Okay, this one, the degrees are the same. The ratio of the leading coefficients would be the horizontal asymptote. That would be y equals 1, which is not the case. And this one, there's no horizontal asymptote, but clearly there is one. Which the following functions could represent f of x as a limit as x approaches 0 from the left? That's what the 0 minus means. F of x is negative infinity. And x approaches 0 from the right, f of x is positive infinity. So this is saying that there's a vertical asymptote at x is 0. And as we approach 0 from the left, that's what 0 minus means, we approach negative infinity, so it'll be something like that. And as we approach 0 from the right, we will approach positive infinity. So it'll look something like that. Okay, so which graph would have that? Well, let's first find out which ones have a vertical asymptote at x is 0. C clearly does not have a vertical asymptote at x is 0. It has one at x is 1. Okay, the rest do have a vertical asymptote at x is 0. Okay, so now which one is it? So I know how the graph of 1 over x squared looks, and I know how the graph of 1 over x looks. Okay, so, and I know as a result, so this is very close to 1 over x squared, because this is just 1 over x squared minus 3x. Okay, the answer should be D, because I know the graph looks like this. Versus for 1 over x squared, it looks like this. Okay, so there's a more mathematically precise way to do it. When we take the limit, we can plug in a number very close to 0, but when we approach 0 from the left, it will be a little less than 0. For example, we can put minus 0.01, and then we can also put like minus 0.00001. That's very close to 0, but a little bit less than 0. So if we plug in, let's just do a even easier number, like minus 0.1. If we plug in x as minus 0.1, what's the y value? This we square it, so it'll be positive. So that's why when we plug in something very close to 0, it's positive. And that matches this graph that I sketched. So it's not A. Similarly, for here, if we plug in something very close to 0, like again, minus 0.001, it would be negative. So that's why it's over here. And over here, if we plug in like that minus 0.0001, this would be negative. This would be negative as well. Two negatives make a positive. Negative as in like minus 0.1 times minus 0.1, whatever number I said, minus 0.1 minus 3. So negative times negative, that makes a positive. So it would be up here again somewhere. So that's why I said it should look very close to this one. Okay, so multiple ways to approach this. I know how these functions kind of look like, so I already knew the answer right away. But you can always just plug in numbers very close to 0, but less than 0, and very close to 0, but greater than 0. Okay, rare species of insect was discovered on a tropical island. To protect the species, scientists moved the insects to a protected area. The population P of the insect T months after being moved is this guy. How many insects were initially discovered? Okay, there's more choices on the next page, but to explain how to do this, initially discovered means when T is 0, right when they got moved. Because that's, so at time T equals 0 months, that's when they just moved into the new place, or whatever the problem said. Okay, so we just want P of 0, which would be, we solve this, it'll be 50 times 1 plus 0 over 2 plus 0. So it should be 25. Let's see if I did that right. 6b. Yes. So I didn't even need the other choices. Okay. Let's move on. A rare species of insect that loves insects in this section was discovered on a... Oh, this is the same problem. 6 and 7 are... Oh, that's maybe asking something different. Okay, so let's read it again. So a rare species of insect was discovered on a tropical island. To protect the species, scientists moved the insects to a protected area. Population P, after 2 months, same function. Now it's asking what is the largest population that the protected area can sustain. Okay, so how in the world do we do this? They're probably asking about end behavior. So we probably want to take the limit as t approaches infinity of our p of t. So we want to take the limit as t approaches infinity of this guy, 50, 1 plus 0.5t over 2 plus 0.01t. Okay, let's distribute this 50 out. Okay, so we limit t approaches infinity. 50 plus 0.5 is half, right? So it'll be 50 times half, which is 25 over 2 plus 0.01t. So as we take t approaches infinity, that's again horizontal asymptote. Degrees are the same. Take the ratio of the leading coefficient. So it'll be 25 over 0.01. Okay, which is 25 over 1 over 100. So we multiply the top by 100, 2500 then. Okay. Okay, limit as n approaches infinity of the sky. Again, horizontal asymptote, do the degree test. Degrees are the same. Take the ratio of the leading coefficient. So 3 over 1, which is c. Okay, hopefully you see a theme here in this practice test. If the graph of y equals ax plus b over x plus c has a horizontal asymptote y equals 2, vertical asymptote at x minus 3, what is the sum of a and c? Okay, so let's take care of the vertical asymptote first. That means the bottom has to be x plus 3. Okay? Oh, my alarm's going off. Okay, so where was that? Horizontal asymptote at y equals 2. Again, degree test, they're the same. Take the ratio of the leading coefficient. So our 2 here should be a over 1, because that's the ratio of the leading coefficients, a over 1. So a is 2 then. So it'll be 2x plus, do we even need this b? That's what I'm thinking now. They want a and c. So a is 2, c is c is 3, sorry, not minus 3. Gotta be careful with that sign there. So the answer should be 5, is that correct? Yes. Okay, so we didn't even need that b. Last one, given the graph of the rational function c of x, which the following could be its equation. So one more guy here. Okay, so here notice there's the horizontal asymptote at, this looks like y equals 1. Okay. There's a vertical asymptote at this value, right? So that would be x is minus b, or x is, you got to be careful with this sign here. X is this minus b. Yeah, okay, let's keep it as minus b. Okay, and there's a hole at x is c. Okay, so when there's a hole, usually that means there's like a x minus c on top and on the bottom. So they would cancel, but because of your domain, x cannot equal to c still in the original guy, because we'd be dividing by 0. That's why there's a hole there. Okay? Even though they cancel, there's a hole because of the domain. Okay, so there should be x minus c and x minus c on the top and on the bottom. So which one does that appear in? It appears in A. It's x plus c here, so they would be whole at x is minus c, which is not the case, so cross B out. There's not x minus c on top and bottom here, and not on D also. So the answer is A, as simple as that, but we can double check the remainder. We were saying there's a vertical asymptote at x is minus b, so it would be x plus b then, okay? And then we were saying horizontal asymptote at y is 1. Well, the degrees are the same because it'll be like x squared plus something x plus something on the top and x squared plus something x plus something on the bottom. So degrees are the same. Take the ratio of the leading coefficients, which is 1 over 1, which is 1. Okay, but clearly the hint here was, or the quickest way to do it was, you see the whole, you realize that there should be x minus c on the top and bottom. Only choice A has it. Okay, hopefully this was helpful for you, and hopefully this is good practice for you if you're studying. Please like and subscribe, as always, if I was able to help you in any way in this video, and hopefully you look out for the next video also. I don't know which topic I'll do next, but I'll for sure do another one, so look out for that video.